So you don't have your test in front of you, but you may remember this question. It said if f of x equals x squared plus 2 and g of x equals the square root of x minus 1, which is true about g of f of x. Everybody seemed to be fine with the composition part. This is a classic example of a combination problem. First we have to compose, and then we have to do something else. In fact, we have to do multiple other things. What's hard for people is when they can't recognize the function. But what I want you to start building is the ability to reason about domain and even and odd, even when you don't know exactly what the function's going to look like. So we start with what we can do. We can compose these. It's not that hard. Everybody did it right. G of f of x just means plug the f rule into the x spot for the g. And we get the square root of x squared plus 2, and minus 1 is outside. In fact, nobody made the common mistake of canceling out the squared or anything. This is as simplified as we can get. There's nothing else you can do. And even I can't look at that and tell you exactly what it looks like. But I can figure out the domain without having the graph. And part of why I can do that is because I know that there's basically only two rules for domain. The definition of domain has to do with x values, in particular about x values that I'm allowed to plug in. And I know that there's only two times I'm not allowed to plug something in. One is when I'm trying to plug a negative into a square root. That's no good. And the other is when I'm trying to plug a 0 onto the bottom of a function. That's no good either. In this case, there's no fraction, so the second rule isn't going to matter. But the first rule could come into play. So if I'm trying to think about the domain in order to rule out A or D, I'm going to look at this equation and I'm going to think about plugging in numbers, maybe even scribble it down on paper if I need to. If I plug in a 1 right here, 1 squared is positive 1 plus 2 is positive 3, looks fine. I don't know what the answer is, some decimal, but it looks fine to plug in positive 3. Well, naturally we'd wonder about negative numbers, and I can think about plugging in a negative number here too, for example, negative 2. And if I do that, negative 2 squared becomes positive 4, plus 2 is positive 6, and I can take the square root of that. I don't know what it is, but I can do it. It will be a real number answer. And so what I start to realize just by trying numbers out is that even if I plug in a negative here, there's no way that the inside of this square root is going to turn into a negative number because I'm squaring the number first, which means that I can plug in any number I want and get a real answer out of this equation. And that ability to plug anything in is exactly what this statement means right here. So D is true. And again, I can see that just by thinking about what numbers I'm allowed to plug in for x. That's what domain is. Now, I also need to determine even and odd. Even and odd is another thing that I can determine without knowing what the graph looks like. It would be easier if I had the graph, but I don't need them. And the reason I don't need them is because there's an algebraic way to do it. If I plug in a negative x into this function, the notation would be I'm going to take g of f of negative x. And when I do that, replacing x with negative x gives me this function. And simplifying this function, negative x squared is the same thing as x squared. Which means even if I flip the sign of x, the answer, the ultimate function I get, is the same as what I started with. That's the definition of an even function. Which means that b is also true. And the correct answer would have been E. It's worth noting just really quickly before we move on that a good way to test yourself is to check that you know what this would have looked like that would have made it odd. This is even because I got the same function that I started with. In order for it to have been odd, I would have to have seen a negative out front and a plus right there so that the answer was the opposite of the original. Let's do number 7, and then I'm going to give you some examples for yourself. Same thing here. We are both composing and then talking about asymptotes and domain and shifts and intercepts. The trap you might fall into is stressing about not knowing what the function is, and the solution to that trap is focus on what you do know. I know what the composition is. This is easy. Everybody got it right. F of g of x. I take the f function, I plug in the g function. It looks like 1 over x minus 1 with a plus 2 at the back, and it simplifies to 1 over x plus 1. Now, this function is actually one that I can visualize, and I can visualize it because I know what the 1 over x function looks like, and I know that adding a constant at the back shifts the whole thing up 1. Now, the reason I know the shape is because I have it memorized. It's not because I did some calculation, and that's why we're adding these functions to your cram account. You need to have these memorized. The shapes, the intercepts, the asymptotes. For this one, 1 over x is this two-part function that looks like this. And normally the horizontal asymptote would be on the x-axis, but I've moved it up because of the k value right there. Now I can use this graph to easily answer these questions. Does this have a vertical asymptote at x equals 0? Yes, it does. It's right here. What is the domain of this function? Well, all x values are represented except for x equals 0, because that's the definition of an asymptote. Right here, at the point where x equals 0, at this vertical line, can't plug in 0. So B is true as well. Is this function shifted up 1? Yes, we've already gone over that. That's the k value. Does this function have a y-intercept? No, it doesn't, because these lines are going to get infinitely close to the asymptote, but they're never actually going to cross. So that's true as well. Looking at that, we can say easily that all of the above are true. Of course, notice that we were looking for the not, but we didn't find one. They're all true. Just like the last one, this one started out with a composition, and you've probably already seen that f of g of x turns out to be 1 over x squared plus 3. Even I couldn't tell you right now what this looks like, but that's okay. I look at my answer choices. I can see that I'm looking for information about domain and range, and about even and odd. Those are things I can reason out without knowing what the graph looks like. Let's start with domain. Domain's about what I'm allowed to plug in or not plug in. I'm concerned in this case about a 0 on the bottom of a function. In fact, I can see right away that if I plug in 0 for x, I will get a does not exist answer for this function, which means that 0 is not in the domain, which means that the domain is not all real numbers. No good. Let's switch down to range before doing even and odd. Range is a little bit harder. You don't just get to check the two scenarios. You need to go back to the meaning of range. Range is what are all the different outputs that I could get from this function. Could I get 0 out? Could I get positives out? Could I get negatives out? And the best way to start to think about range is try plugging some numbers in and see what happens. We've already seen that I can't plug 0 in. So plugging in positive 1, 1 over 1 is 1, 1 plus 3 is positive 4. If I try plugging in negative 1, this squared will switch it to a positive 1. It'll also equal 4. Now what's important is that I just noticed that even if I plug in negative numbers, my answer is always going to be positive, which means actually that negative numbers can't be the output to this function, which means that the range can't be all real numbers because it can't include negatives. I don't really know what the range is, but I know it's not all real numbers, and that's good enough for now. Even and odd, you know how to check. We're going to plug in a negative x. If I take f of g of negative x, I end up with 1 over negative x squared plus 3. And that simplifies because the squared cancels that negative out, negative times a negative. That simplifies to 1 over x squared plus 3. I got the same thing that I started with, which means by definition, this composition is an even function. Okay, so as you saw, the correct answer was B. Let's look at y. You should easily get the composition to be this. Notice that I can't simplify it anymore. The square root symbol includes that -1, so you can't combine like terms. The first one that I would look at is the y-intercept. I think this is the easiest one to see. The y-intercept is the point on the y-axis, which is the same thing as saying the point where x equals 0. So if you ever need to check a y-intercept, all you have to do is plug in 0. If I plug 0 in to g of f of x, 0 squared is 0, and 0 minus 1 is -1. And boom, right away, I can't take the square root of -1, which means that when I plug in 0, this function does not exist. It's undefined, which of course means that it doesn't have a y-intercept, it's certainly not 1. It also means that 0 is not in the domain. So from there, it seems natural to me to talk about the domain since I've already seen that 0 is not in it. Now, just because 0 isn't in it doesn't really tell me what the domain is, it just tells me it's not going to be all real numbers. If I try and understand what this is saying that the domain includes numbers like -5 and -10 and -7 and even includes -1, but doesn't include numbers like 0.5 or -0.5 or 0. That's like in the gap between the two. And then the domain does include 1 and 5 and 10. The way to check that is to look at your equation and think about what would happen if I plug in different kinds of numbers. If I plug in -1, -1 squared is +1. +1 minus 1 is 0. The square root of 0 is 0. And sure enough, I get an output that's a perfectly fine output. 0 plus 1 is 1, no problem. If I plug in -0.5, when I square it, it becomes positive 0.25. But then positive small decimal numbers -1 are going to equal negative numbers inside. And that's no good. I can't take the square root of them. In fact, even if I plug in a positive decimal, 0.5 squared is also 0.25. And subtracting 1 gives me a negative decimal inside the square root, which is no good. And that's why the domain is missing a chunk in the middle. As soon as we get up to +1, though, 1 squared is 1, and it starts being okay again. 2 squared is 4, and 4 minus 1 is +3, etc., etc. This is the correct domain. Now, I'm really convinced. Maybe you're not convinced. Maybe you see that it's a possible choice. So let's consider this a maybe and keep checking everything else. Linear. Well, this question is here for people who don't know order of operations, who accidentally canceled -1 and 1 and took the square root. But you're smarter than that. It's not linear. It's not a linear function. It doesn't look like y equals mx plus b. Range. Remember from the last one that range is all about what you can and can't get out. You should notice by now that a square root, you can't get a negative number out of a square root. This, no matter what I plug in, is going to be positive. And then adding a 1 is just going to keep it positive, which means I can't get negative numbers as outputs for this function, which means it definitely doesn't have all real numbers as its range. Of course, B is the correct final answer, but you would have to really convince yourself of that in the end. Okay, the last one's super fun because this is one finally that we actually know the shape of. When we composed the two, you should have had this pretty easily. Notice that this is the natural logarithm graph flipped and stretched and shifted up 1. The regular ln graph, you need to memorize this, looks like this. If I flip it over the x-axis, my graph's going to look like this. And it's going to stretch, which maybe means it looks a little wider than that, something. Not totally sure. It's also going to shift up 1. So again, this is really loosey-goosey, but basically I'm thinking about a shape that looks like this. And let's see if that's enough to answer the question. Well, yeah, for sure. There's a vertical asymptote at x equals 0. That's true. Is this even? No, that blue line doesn't match anything. It doesn't have y-axis symmetry. Is the domain all real numbers? Nope, not at all. Negative numbers are not in the domain of this function. Has the graph been reflected over the x-axis relative to its parent? Yes, it has. That's what the negative does. So both A and D are true.